Hi, what we're going to do today is we're going to check about what are linear models and what does that have to do with rates of change. So kind of a quick objective here. We want to find the slope of a line, use that slope to write the equation of a line, and tell what the slope means in real life, and maybe follow that up with graphing. So what is the slope of a line? It's the measure that the line rises. Notice this line from this point to this point rises this much, and it runs this distance. So it's how much does it rise compared to how far it's run. The rise is delta y. That's y2 minus y1. The y values tell us how high something is. Delta x will tell us the run. Delta is this symbol here. x2 minus x1 will tell us how far it goes. So what you can do is you can use that to talk about the slope of a line. After you calculate the slope, it tells you something. If it's positive, the line is rising. Here's something with a slope of 1/5. It rises 1 for a run of 5. Over here, there is no rise. The slope is 0. Here, the line is going down. It drops 5 as it moves over 1. Negative 5 over 1 is a negative slope, and it shows it's decreasing. And here's an undefined slope. Okay, how do we find the equation of a line? Well, we can pick any 2 points. And the first thing you do is determine the slope. Once we have the slope, we're going to use the point slope equation of a line. Y minus y1 equals m times x minus x1. And what are the variables? Well, y and x are going to stay y and x. Those are variables that represent all the xy points in the line. x1, y1 is our first point that we used for finding the slope, and m is the slope which we calculated earlier. Okay, once you get that, you get the equation of a line. Here's a good example. Find the equation of a line that has a slope of 3 and passes through the point 1, negative 2. This point's going to be our x1, y1. This is our slope. Solution. Well, first of all, you write point slope form. You substitute in the point 1, negative 2 for x1 and y1. Y minus negative 2. M is my slope, 3, times x minus x1. You simplify, and then you solve that for y. There's my equation. The slope is 3. The y-intercept is negative 5. Both these numbers have significance. The slope in front of x, the coordinate of, or coefficient of x, is 3, and the y-intercept is negative 5. So that's ratios and rates of change. And what do they mean? Well, what does it mean when you find them? If they have the same unit of measure, it's a ratio. If they have different units of measurement, it'll tell us the rate of change. Here's an example of one with different units. Colorado had 3,827,000 people in the year 1995 and 4,665,000 people in 2005. What's the rate of change of population over years? Well, we find the change in population over the change in years. You simplify that and you get 83,800 people per year. That's the rate of change of that population. It's really telling us that it increased that amount. A negative rate of change would tell us it was going down. Okay, here's another problem where you're actually talking about water skiing, and you hit this ramp. It goes up 6 feet over 21. Notice those are both feet. So rather than a rate of change, you're going to have a ratio. The ratio of the rise to the run is 6 over 21, or 2/7. It has no units. The feet cancel out, and it's the rate of change in 2a is an average rate of change. It's always calculated over an interval. Now, how do you graph that? Well, you graph it using slope and intercept. This b is my y-intercept, and m is my slope. This one will hit at the y-axis and have a slope of 2. This one has no slope, 0 x's plus 2, a y-intercept. So here's the first one. Start at 1. Go over 1 up 2, that'll find you another point. Y equals 2x plus 1. Y equals 2 is a horizontal line with no slope. And if you get a different kind of equation, solve it for y. Now you know the slope is negative 1/3, it's going down, and 2 is my y-intercept. And that pretty much summarizes what we're